All right. Yesterday we talked about variation, standard deviation, being able to calculate it. A lot of it is just if you utilize your calculator, it's going to be a lot more helpful. As I talked about when you set up your table, if you work yourself sideways and then work yourself down, calculating your standard deviation. It depends on whether you're dealing with a sample or population. If you're dealing with a population, you have to be able to distinguish whether you have a population or a sample. Okay, and most of the time it will be given to you. Most of the time it will be given to you as a population or sample. They'll be told to you if you have a population or you have a sample. You just have to make sure that you use the correct formula. When you're using a population, your standard deviation or your variance is calculated by the sum of the values minus the mean divided by our sample size, our population size. Okay, so that is your variation. When you're dealing with a sample, we signify this, our variation, with an S. It's still the same as your value minus your mean divided by your sample size minus 1. So it depends on whether you're doing a population or sample, which you divide by. And this is your variance. To calculate your standard deviation, your standard deviation is just the square root of your variance. This is what you need to calculate your population variance and standard deviations. Once again, the only thing we can do right now is just set up tables. Now, where standard deviation affects you, when you go to college, because most teachers don't do it here in high school, but when you go to college, there will be professors that will grade on a curve. They will grade on a curve. Well, that curve is the standard, or is a normal distribution curve. What a professor will do is they'll take the average of the class. Say it is 66 is the average of the class. The standard deviation that he has is a value of 8. What this will mean for a grading scale. This standard deviation will be the width of each grade. So we have a value of 66 This is the middle C's. He will go, all right, I will go 4 up and 4 down to give me 62 and 70. These will be my C's. Anything from 62 to 70 will be my C's. I will take another standard deviation. This will be your B's, all the way up to 78. He'll go 8 below to give me 54. These will be the D's. Anything below a 54 will be failing. Anything above a 78 will be an A. What that does is that puts a competition between grades. It compares your grade to 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 your grade. Everybody's grade is compared to each other's grade now. It's a dog-eat-dog world. It's a competition world for jobs and for anything that you have out there. When you get to college, it's a competition of grades. It's the way they filter out people in majors. That's how they filter them out. Because they'll put comparisons, they'll start competing, have you compete with your grades in those classes. And if you're in this range down here, you know what? You're going to start filtering away. Some of these people will start filtering away here. And the people who will stick around are the people that are getting the A's and the B's and the C's also. Some of the C's. Some of the C's will stick, some of the C's will not. I still remember one of my engineering classes in college. Get my test is thermodynamics class, thermo class. Get my test back. Okay, my thermo class. This is how they did. This is how thermodynamics works in college. Okay, if you're going to be an engineer, you're going to take thermodynamics. Okay, mechanical engineering. Okay, you had 3 professors. 3 professors. They had 3 different classes for thermodynamics. When you took your test, all the classes came together on a Friday from 2 o'clock to 5 o'clock in the afternoon. You had 3 hours to take the test. On that test, each one of the teachers did 1 problem. So we had 3 teachers, each 1 problem, so you had 3 problems. They gave you 3 hours to do the test. And you needed every bit of it. I remember one of my tests getting back, and I got 52 on it. It's like, ooh, ouch. 52. Do the grades up there. 52 was a low B. It was a B minus. Because the average ended up being about a 42. The average on the test was a 42. Got me into low B's for a 52% on the test. That was I think the max grade on that was like 78. That was the max grade. Welcome to college. Okay, so when you get into a very competitive field like that, okay, mechanical engineering, all the engineering courses were very competitive. They look to filter people out. I filtered out of chemical engineering real quick. I walked into organic chemistry, filtered me out real quick. You have to pick and choose your battles. Wasn't going to battle organic chemistry. But that's how standard deviations will affect you when you get to college. Because when the professor said they're going to grade on the curve, okay, what you basically, they hand back the test. I got that 52. It's like, oh, ouch. Then you sat there waiting. Okay, what's the average? What's the average? Average was a 42. You feel pretty good about yourself then. Feel pretty good about it. 52, you initially don't feel pretty good about that. Any other questions about standard deviations? How to calculate them? Set yourself up a table. Work yourself through the table. It takes patience to get through the problems. Mathematically, once again, not a new and odd thing. But concept-wise, it's something new for you. It is something new. Yes, I have a mechanical engineering degree. Why am I sitting here being a teacher? Because I couldn't see myself sitting in the cubicle in a think tank with a bunch of other people that are really smart, and I'm not that smart. So, I enjoy this aspect a lot better. I have a lot more freedom. Okay, last section in this chapter. Measures of position. We'll talk about box and whisker plots today. My cat food plot, box and whiskers. Whiskers. Okay, and we'll talk about a z-score for data values. Median, we know the median. We've already talked about that. The scores are exactly in the middle of a set of data when listed from least to greatest. Okay, that middle number when you listed from least to greatest. Lower quartile. It's a median of numbers, or it's the median of the set of data below the median. The median of the set of data below the median. The median of the set of data below the median. That's your lower quartile. Sometimes this is called first quartile. They put a Q1 there. Sometimes it's called the first quartile. Lower quartile, first quartile. Potato, potato. The upper quartile is the exact same thing, but it's the data above the median. The median of the set of data above the median. The median of the set of data above the median. This is the third. The third quartile. Q3. Why do we jump the second quartile? Well, the second quartile is the median. Your median is the second quartile. Basically, what you're doing with quartiles, you're splitting your data into 4 sections. You're splitting your data into 4 sections. The interquartile range. Your interquartile range is your upper quartile minus your lower quartile. Q3 minus Q1. your interquartile range. Let's determine median, upper quartile, lower quartile, interquartile range, and determine, oh, I'm sorry, forgot one last thing. Outliers. Outliers. Okay, we talked about outliers. What's an outlier? Well, it's a number that doesn't quite fit into the set of data. Okay, number doesn't quite fit into the set of data. Okay, average household income in that local school district, about $60,000. That's an average household income. $60,000. Bill Gates wants to move out of Texas. He throws a dart out of dartboard. There's a map there. It hits little Dalton, Ohio. He buys the Hasselman farm out here. The Hasselman Ponderosa out here, he buys that. And he wants to build his house right up there. Average household income was $60,000 in our fine little community. Bill Gates moves in. Lives out there now. Household income, average household income just went up to $1,200,000. $1.2 million. I don't know about your household. My household doesn't do that. Doesn't go there. Maybe over my 30-year span of living and teaching, or 35 years, I might finally get that $1 million. But it took me 35 years to do that. That would be an outlier. His average household income would be an outlier. Using the average salary in that local school district would not be a good indicator of that local school district. What would be a good indicator would be the median, because his number goes way out to the right. So the median moves from here to here. One spot. So rather than $60,000, it's $60,050. All right, just take this set of data. Okay, to find an outlier, okay, we take the interquartile range and multiply it by 1.5. So you have 1.5 the interquartile range. We take 1.5 times the interquartile range. And then we add that to the upper quartile and subtract it from the lower quartile. So you add it to the upper quartile, subtract it from the lower quartile. Any number that lies outside of that range will be an outlier. And most of the time they stick out like a sore thumb. Bill Gates sticks out like a sore thumb. If I look at this set of data, there's probably a good shot 56 is going to be an outlier. Why? Because I'm 7 through 25, and then all of a sudden we got 56. Okay, but just take a look. First off, let's find the median. What's your median? What's the median? Landry, what's the median? 14's not even up there. How'd you get 14? Yeah, because if I went here, 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 oh, I got two numbers in the middle. So what do I have to do? I have to take the number between them, which is 14. Now the question is, okay, this is my median right here. This is my median at a value of 14. The lower quartile is the median of the set of data below the median. What is the lower quartile? What do you think the lower quartile is? Molly? The value of 10. That is correct. It is 10 because here's my median right here. Here's my set of data below the median. So I have three values. Even though I use 13 to find the median, 13 is still below the median. The upper quartile, Aubrey, is what? 18. Your inner quartile range. Your inner quartile range is Q3 minus Q1. So we have 18 minus 10, which is a value of 8. Now to find if we have outliers, we take 1.5 times the inner quartile range. So we have 1.5 times 8. Which should come down to 12. Now to find if we have outliers, we take this value 12, add it to the upper quartile, subtract it from the lower quartile. So we have 18 plus 12, and then 10 minus 12. Because this is Q3 and this is Q1. So we take this 1.5 times the inner quartile range, add it to the upper quartile, subtract it from the lower quartile. So we get a value of 30 and negative 2, but really we should just use a value of 0. We have from 0 to 30. Any number that lies outside that range will be classified as an outlier. So our value of 56 lies outside that range, so it's going to be an outlier. Now, something you've done this before, because I think when you're probably in elementary or 8th grade, 7th grade math, you did what was called a box and whisker plot. Again, I call it my cat food plot, because there should be cat food that's called box and whiskers. It's a distribution curve depending on the median, lower quartile, upper quartile, and the upper and lower extremes. We have something called a 5-number summary. A 5-number summary, which is your lower extreme, Q1, Q2, Q3, and your upper extreme. So you have lower extreme, that's your smallest value. your lower quartile, your upper quartile, your median, which is your second quartile, and your upper extreme. We use these five numbers to draw our box and whisker plot. Let's see, we're going to use a set of data up here. So counting up by tens. Once again, you probably have done these in 8th grade, 7th grade math. First thing you do, draw a vertical line at the median, upper and lower quartile. So our median is 14, and 10 and 18 are upper and lower quartile. So we have 10, 14, and 18. Draw vertical lines there. Construct a rectangle using the Q1, Q3 as the sides. This is your box. So there's our box. Place a point at your upper and lower extremes, which are 7 and 56. Then draw a line from your outer edge of the box to the points. These are your whiskers. Once again, the median upper and lower quartiles divide your data into 4 equal groups. Something that's also very common, especially at this age level, to know is what is called a percentile rank. Why? Because you've taken an ACT test. When you deal with a percentile rank, the percent of scores that are at or below a particular score. I'm sorry, just below. Percent of scores that are below a particular score. Once again, where you see this is when you take an ACT test and you get a grade back, when you get your ACT results back. They don't give you an A, B, C, or D. All they do is they give you a percentile rank. Basically, they're telling you what percent of scores were below your score in the United States. If you score in the 75th percentile, that means 75% of the scores were below you. That's pretty good. If you scored in the 90th percentile, that means 90% of the scores are below yours. That's really good. If you score in the 10th percentile, that means only 10% of the scores were below yours. Not too good. Basically, with a percentile, you're divided into 100 groups. The lower quartile, Q1, is also called the 25th percentile. That means 25% of the scores are below your score. Lower quartile is the 25th percentile. Median would be the 50th percentile. And the upper quartile would be the 75th percentile. When you get older and you start to have children in your family, you become a mom and a dad every month. You have a well baby checkup that you have to go to the doctor's office. This well baby checkup also starts showing some conversation points amongst people that are common to you, which means they've just had a child also. You may be in birthing classes with them. You've had conversations with them. You'll get a network of people that are close to your age that have children the same age. And there'll be a little bit of bragging rights in regards to this, because every time you take a baby to the doctors. We talked about before, when you're born, you become a statistic, because they put you on a meat train and measure how much you weigh, and then they try to stretch you out. Every time you go to the doctor, they do the exact same thing. They put the baby on a meat tray. What's the weight? Really, it is a curved meat tray. What's the weight? Okay, think about it. Babies don't stand. Okay, so you can't stand the baby up and say, okay, let's look at the scale. So they put you on the meat tray. And then they try to stretch out as best as possible. With those numbers, what the doctor will come in and start doing is they'll take an age and they'll stretch that age up to, okay, what is the height and what is the weight? What is the height and weight? And they will come in and tell the moms and dads that are sitting here, your son, in regards to weight, is in the 75th percentile. Or your daughter, 75th percentile, your son or daughter is in the 80th percentile with height. And then all of a sudden, all these things start going through the parents' brain. Man, my son or daughter are going to be really tall. Okay? They start formulating all these ideas. It means absolutely nothing. It means absolutely nothing. What the doctors are checking for is the health of your child. Are they developing like they should? If they're in the 10th percentile with respect to weight, they're going to say, we need to continue to increase the feedings on the baby. Because we need to continue to put weight on this. And if it thinks it's every month it's still the same, they're going to maybe look to see, is there other underlying conditions that's occurring. But it becomes a little bit of a bragging right, and it's a conversation point. You'll go to somebody's house, the play day, they have the same age baby, they'll start talking about, yeah, doctor said we're in the 50th percentile in weight and 75th percentile in height. Okay, and there'll be a conversation that goes on. Just wait. Your parents did it. Your parents did it. You'll do it also. They may not admit to it, but standard scores. Last thing we're going to do is standard scores. It's a position of scores in terms of standard deviations away from the mean. The position of scores, according to the standard deviation in terms of standard deviations away from the mean. This is also called a z-score. Also called a z-score. We'll just learn how to calculate it here. The entire second 9 weeks will be based on a z-score. We will calculate z-scores and utilize z-scores a lot the second half of the year. How do we calculate a z-score? We take the value, we subtract off the mean, and we divide by the standard deviation. Take their value, subtract off the mean, and divide by the standard deviation. So if we want to calculate the mean, we have to add these up and divide by 5. So we add them up, 74, 83, 92, 87, 94. We add them up, divide by 5. What do they add up to? Throw the number out, somebody. How much?
86.
86? What do they add up to? The bar average is 86. What's 430? So the average is 86. Then we go x minus x bar squared. We're going to calculate our standard deviation. So we have 74 minus 86, then we square it. So we have 256. No. Yeah, 254. Okay, we find our standard deviation, and then we calculate the z-score on that. See what you can do with your homework tonight. Okay, once again, good practice in regards to standard deviations. Just one side, I'll post solutions. Adios, have a good day.